last part of your packet 1 of your summer assignment deals with mole concepts. So, the molar mass of this is ammonium phosphate is what? So to calculate the molar mass, we got to calculate the mass of 1 mole, right? Molar is 1 mole. So let's make explicit how many atoms we have in this compound. So we have 3 nitrogens, we have 12 hydrogens, we have 1 phosphorus, and we have 4 oxygens. And let's transform those in weights. So you have 3 times 14, and then you have 12 times 1, and then you have the phosphorus, which is 31, and then you have 4 oxygens, which means 4 times 16. You add them up, 149.09. Then 32. 1 mole of blank contains the largest number of atoms. Well, let's see. Here we have 8 atoms in all. Here you have 10 plus 8, you have 18 atoms in all. This one you have 2 plus 3 sulfurs plus 12 oxygens for a total of 17. This is 3 plus 1 plus 4, so this is 8, and this is 2. So it looks like the highest one is 32B. 33. We have this many grams of a sample of glucose, that's the formula for it, and contains how many moles of glucose. So how many moles are in this many grams? So first of all, we got to know what is the molar mass of this compound, right? So this is 6 times 12 plus 12 plus 6 times 16. And when we do this, we have, so this is the molar mass of glucose. Okay, then we take the 30 grams, 30.5 grams of glucose. Okay, and we got to convert this one in moles. So what we do, we know that 1 mole is made of this many grams, okay, of the molar mass. So at this point, we divide the 30.5 by the molar mass, which we calculate from here, and we have C as an answer. Then 35. How many grams of calcium nitrate contains 24 grams of oxygen atoms? So for this one, what is the molar mass of this? Well, first of all, okay, so let's calculate the molar mass of the calcium nitrate. So we have 1 calcium, which means 1 calcium has a mass of 40.1. So we have 40.1 for calcium, and you have 2 nitrogens, so 14 times 2 is 28, and we have 6 oxygens, so 6 times 16 is 96, and we add them up, and we have 96 plus 28 plus 40.1, we have 164.1. Those are the grams of 1 mole of calcium nitrate. Now, what we need to do also is to create the ratio between the atoms, okay, and this compound. So first of all, how many moles are contained into 24 grams of oxygen? So we have 24 grams of oxygen, right? And we know that 16 grams is 1 mole of oxygen. Okay, so 24 divided by 16, so we have a 1.5 moles. Okay, so basically now the question is, first of all, how many moles, let's solve this one first, how many moles of calcium nitrate contain 1.5 moles of oxygen atoms. At this point, what we do is we take our calcium nitrate, okay, let's take the aqueous solution of this and dunk it in water, and let's see what happens when we're going to have 2 calcium, right? Calcium plus 2, okay, the ion, and we also have 2 nitrates, okay, in the aqueous, which we can kind of break down uh, farther, okay, and we can say that calcium nitrate, okay, deals, okay, so um, okay, so basically for every 1 mole of calcium nitrate, we have 6 moles of the oxygen. Now, the question is, what do we do instead if we have 1.5? So to move from the oxygen to the calcium, you got to divide by 6. So if we have the 1.5 and you divide by 6, then means that you have 0.25 moles of calcium nitrate. Now, knowing the mass of 1 calcium nitrate, how many of the calcium nitrate, okay, how many grams would we have? So those are the moles. Each mole has a mass of 164.5, so 1/4 of it, right? So we got to multiply the 0.25 by the 164.1, and this is how many grams we should have, which is a 41 grams, okay? And this is for number 35. Okay, so how many molecules of methane are contained in this many grams of compound? So first of all, 48.2 grams correspond to how many moles? So methane is a 12 plus 4, so this is 16 grams, okay, which is roughly 3 moles. If those are the moles, okay, how many molecules do we have in there? So we know that 1 mole contains 6.022 times 10 to the 23rd molecules. So this is about 18, blah, blah, blah. So let's say it's 18 times 10 to the 23rd. Remember, technically, you shouldn't use the calculator, so it doesn't really matter the exact number, but this one is the same as 1.8 times 10 to the 24th. So this is your choice. Then, what number of moles of O2 is needed to produce this many grams? So you're producing the P4O10. So to produce this, you need phosphorus and you need oxygen. So you need 4 moles of phosphorus and 5 moles of oxygen in order to balance the reaction. Now, you want to produce 14.2 grams of this. How many moles would that be? Well, 284 grams is 1 mole because they said so here. Okay, so this is about 0.05 moles. Okay, so if we are producing 0.05 moles, how much of this will we need? Well, if we are producing 1, we need 4. So to move from here to here, we got to multiply by 4. So to move from here, we got to do the same stuff. We got to multiply by 4, which gives us a 0.25 moles. So that's your answer. Then 38. For this one, so which one of those gases contains the greatest mass? Well, all of those, if you remember the equation PV equal nRT, you see that the number of moles is equal to PV divided by RT. Now, we are at standard temperature and pressure in all of those cases, So P and T are the same. Also, R is a constant. V apparently is also a constant. So this means that the number of moles for every single one of those gases is the same. So which mole has the greatest mass? Well, this one, right? If you look at your periodic table. Then, number 39. So molarity of the aqueous solution containing this many grams of glucose in this many liters. So this is your mass. This is the volume. Molarity, we know there is moles of solute over liters of solution. So this means we need moles. So this 75.3. So if we have, how much is the molar mass for the glucose? What is 6 times 12 plus the 12 of the hydrogen plus the 6 times 16. So you have for this one, you have a mass of 180 grams per moles. So this means that this many grams corresponds to 0.42. So we have a 0.42 moles divided by 35.5 times 10 to the negative 3 because it has to be liters. And we have a 11.8 moles per liter. So that's your answer. Now, how many milliliters of this solution contain this many grams? So we are looking for the volume. We have the molarity, we have the grams. But again, molarity works with this equation here, so you need the moles. So how many moles are there? Those are the grams divided by 40 grams per moles. Okay? We have a point, so we have a 0.625 moles of sodium hydroxide. So the volume has to be, according to this equation, it has to be equal to moles over molarity. So moles are 0.625 divided by 0.123. So those are moles. Those are moles per liter. And this is 5 liters, which means technically this number here. And the last question for this packet says the following. So we want the total concentration of ions. So this compound, sodium carbonate, is made of 2 sodium and 1 carbonate. Okay, so we are starting with 0.036 moles per liter. Okay, so let's remove the per liter, it doesn't really matter. So this means that we have a 0.0, but let's leave it per liter, 0.072 moles per liter, and this is 0.036 moles per liter. So what is the total concentration? Well, it has to be the sum of those. So 0.072 plus 0.036 gives you a 0.108 molar solution, total concentration of ions.